Okay, let's look at the 10.5 continued. All right, let's look at the Schroeder-Bernstein theorem, all right, which states that if the cardinality of A is less than or equal to the cardinality of B, at the same time, the cardinality of B is less than or equal to the cardinality of A, then the cardinality of A is actually equal to the cardinality of B, right? So let's do that. All right, so since the cardinality of A is less than or equal to the cardinality of B, we know that there exists a one-to-one function f from A to B. All right, so that's given. And since the cardinality of B is less than or equal to the cardinality of A, so by definition, there exists a one-to-one function g from B back to A. Right? So these two are given. Right? And what we want to do is we're trying to come up with a bijection. So first thing we do is we're going to tweak this g so that it becomes also one-to-one and onto, right? So here's the easiest way to construct a onto function, right? Then problem is g does not hit all of the elements in A. So we're going to collect all the elements that G actually hit. So this will be just a range of G, so which can be also written as G of B, right? So if you restrict the codomain to the range, then it automatically becomes onto, right? So we're going to define G1, right, which goes from B to G of B by G1 of X is equal to G of X, right? So G1 is the same function as G, only difference is that the codomain is used to be A, but we shrink it so that it becomes onto, right? So this guy is still one-to-one because the original function G is one-to-one, but since the codomain is shrunken to the range, so this is also onto, so it's a bijective function, right? So this is by definition or by construction. All right, so you have a bijection from B to G of B, right? So we're going to call it G1, right? So this is 1 to 1 and also on to at the same time. All right, so if you have a bijective function, we can talk about its inverse. So its inverse function, G1 inverse, is going to be a bijection from G of B back to B, right? We know that it's a bijection, so inverse is also bijection, so it's one to one and onto, right? So I'm just using line number 3, right? So we have an inverse function going from G of B back to B. So so that's G1 inverse, and this guy is 1 to 1 and on to. All right. And another thing we can do is we can construct a one-to-one function from A to G of B, which is a subset of A. All right. So 5, right? This is pretty easy to construct because there's a one-to-one function from A to B, and there's a one-to-one function actually and onto from B to G of B, right? So we just have to compose it. So we know that if you compose G1 of F, right, this guy is going to be a one-to-one function from set A to G of B, right? This might not be onto, but we know that it's a one-to-one function, right? But this is a one-to-one function from A to its subset. So G of B is a subset of A, right? So by definition, so this comes from, let's see, F. So line 1 tells you that the F is 1-to-1. And line 3 tells you that the G1 is 1-to-1. Right? So by the theorem we previously proved, we know that 6, right? If there's an injective function from a set to its subset, then there's going to be a bijection. So there exists a bijection H from A to its subset G of B, right? So this is going to be not only 1-to-1, it's going to be onto, because it's a bijective function, right? So this is by previous theorem we proved. All right. So we have a bijection from bijective function from A to G of A, G of B. So this is H, and this is 1-to-1 and onto. Right? Remember that what we're trying to do is we want to come up with a bijection from A to B. Right? Now we can easily construct that because from A, there's a bijection from A to G of B. Right? And there's a bijective function from G of B back to B. So we can just simply compose H and the G1 inverse. We can get a bijective function. All right, so 7. All right, so therefore we have, let's see, we have to use H composed with G1 inverse. This would be a bijective function from, all right, from A to B. All right, so this is 1-to-1 and also onto, right? Because we know that, let's see, G1 inverse is 1-to-1 and onto from line 4, and the H is 1-to-1 and onto from line 6, right? The composition is still going to be 1-to-1 and onto, right? Then the conclusion, right? Therefore, since we found a bijective function from A to B, we know that cardinality of A is equal to cardinality of B, right? So this comes from line 7, right? So this is the Schroeder-Bernstein theorem. If you think of these as inequality between real numbers, this is an obvious statement. But since we're talking about we are defining these inequalities based on the existence of injective function, so we have to show that if you have an injective function both ways, which implies that actually you can find a bijection between them. All right, that's it. I hope that this was clear.